Abdullah, please speak up. Then I will start. Have we completed our first chapter, chemical reaction and equation? Abdullah, please speak up.
Sir.
Uh, we have completed first chapter, right?
Yes, sir.
Okay. Your voice is so low. Now see, I'm going to start the refraction of light. Today we are going to start refraction of light. Let's start. Do you know what is refraction of light? Anything about refraction of light? Abdullah? So see, I'm going to explain it. See, when light enters from one medium to another medium, from one medium to another medium, it bends. It bends. This phenomena is known as refraction of light. This phenomenon, this phenomena is known as refraction of light. So see, it is very important to know that when a light travels from one medium to another medium, it bends, and this phenomena is known as basically a refraction of light. Refraction of light. So I'm going to represent by a diagram how it bends and why it bends. So basically, light has different speed in different medium. That means light has a speed of 3 into 10 raised to the power 8 meter per second in air or vacuum, or light has a speed of 2.5 into 10 raised to the power 8 meter per second in glass. So basically, due to this change in speed of light, when light enters from one medium to another medium, it bends. Are you getting my point, Abdullah, Hamna?
Yes, sir.
So basically, I'm going to show you refraction through rectangular slab. refraction through a rectangular glass slab. Refraction through a rectangular glass slab. So first of all, we are going to have a rectangle glass slab in the shape of rectangle. This is our glass slab. Please write up to this and write the topic. Then let me know. Please write the topic, then let me know. I will draw the diagram and explain. Hamna, let me know when you are done with this.
Sir, done.
Very good. Abdullah, are you done with this?
Yes, sir.
Okay. Now going to show you refraction through rectangular glass slab. Now see, this is our rectangle. No, wait a minute. I'm going to make it a perfect rectangle. This is our rectangle, a rectangular glass slab. This is glass slab. As you know that glass is more denser. Do you know what does denser means? Anyone? This is glass and this is air, and then again air. Both of you, Hamna, do you know denser or rarer? Abdullah, Hamna. See, when a light is incident on the surface of glass slab, when a light is incident on the surface of glass slab, we will have normal like this. See, air is a rarer medium. Air is a rarer medium, and glass is denser medium. And glass is denser medium. Again, it comes into air. So air is basically rarer medium, that I already told you. What I want to tell you is that when a light ray comes from rarer to denser medium, it bends towards the normal. It bends towards the normal. Now see, for this surface, this is incident ray. But for this surface, and this is a refracted ray. This is basically a refracted ray. Again, it will pass through this surface of uh, glass slab, and you know that this is our again normal. This is our again normal, and when light goes from denser to rarer medium, this is rarer medium. When light goes from rarer to denser and then denser to rarer medium, it bends away from the normal. It bends away from the normal. So this is basically the same as this part is same as this part. And what I want to tell you is that in the reflection part, we saw angle of incidence. Angle of incidence is what? The angle between incident ray and the reflected ray is called angle of incidence. Sorry, the angle between incident ray and normal is called angle of incidence. In the same way, here we have I. What does this I means? I means basically angle between incident ray and normal is called angle of I. I1, we are going to do it, and this is angle R1. And then again, this will be I2. This will be I2 because for this surface, this is incident ray, and this is basically R2, also known as emergence angle. We will talk about it after a while. Hamna, Abdullah,
Yes, sir.
Hamna, do you get it? What I explained just?
Yes, sir.
Abdullah, very good. Again, can you tell me I1 or R1, which one will be greater or equal? They will be which one of them will be greater to one another? What do you think? I1 greater than R1, I1 less than R1, I1 equals to R1, or option D, I'm going to give you A, B, C, and then D. Option D, none of this. Can anyone tell me?
Sir, C.
C. Hamna, can you look at the diagram? This diagram, if you will look at the diagram, this will not be true. Abdullah, do you have any answer? See, Hamna, we measure angle with reference to this normal. So this is our surface of glass. Now a ray comes like this, and where it incident like this point, we have a normal. We have a normal, and you know that this is basically angle I. Hamna, are you getting my point? This is incident ray, this is normal, and this is angle of incidence. Is that clear?
Yes, sir.
Now see, this is rarer and this is denser. So what I told you is that when a ray comes from rarer to denser medium, it will bend towards the normal. Okay, are you getting my point? Now,
Yes,
can
sir.
you look at the diagram, and what is angle of refraction? The angle between refracted ray and the normal is called angle of refraction. So angle just can you see the angle I will is greater than angle R? Since it is moving towards the normal, so I is basically I1 is greater than R1. Are you getting my point?
Yes, sir.
We are measuring the angle with the reference to normal, and since light traveling from rarer to denser medium, that's why R is smaller than I. Now again, just suppose this is the this surface, and now you know that for this surface, this is incident. Yes or no? This is
Yes, sir.
incident, and at this surface, you know that this is your normal. Now for this surface, the light ray traveling from denser to rarer. Whenever light travels from denser to rarer, it will be away from normal. So if it is I2 and this is R2, can you tell me which one of the following option is correct? No, no. Can you tell me which one of the following option is correct?
Sir, I2 is less than R2.
I2 is less than R2, or you are going to say R2 is greater than I2, right?
Yes, sir.
So always remember, this is very important to note that when a light ray travels from rarer to denser medium, it bends towards the normal because speed in rarer medium is greater than speed in denser medium. And when a light ray traveling from denser to rarer, it will move away from the normal because speed in denser medium is lesser than speed in rarer medium. So please draw the diagram and write this option in question form and tick on the correct answer, and again this option and tick on the correct answer. Then I am going to write some points regarding this which is important. Abdullah, is your mic good?
Sir, done.
Abdullah, are you done?
Yes, sir.
Whenever light travels from one medium to another medium, it will bend. When light travels from rarer to rarer, okay, rarer to denser medium, it will bend towards the north, towards the normal. And whenever it will bend towards the normal, the angle of refraction will decrease. The angle will decrease. And when light travels from denser to rarer medium, it bends away from the north. It bends away from the normal. So please write it and let me know if you're done.
Sir, done.
Very good. Abdullah.
Sir, done.
Now see, we have a term that is lateral displacement. What is lateral displacement? So basically, you can see the light was traveling. Wait a minute. Light was traveling on this path, but due to refraction, it goes on this path. So basically, this distance is called lateral displacement. This distance is called lateral displacement. Lateral displacement. Before bending, it was traveled in this path, but after bending, the original path is this. So the distance between these 2 points, basically these both are parallel to each other. So this distance is called lateral displacement. Is that clear?
Yes, sir.
Please pick it. Let me switch on. And let me know when you are done with this. Okay, Hamna. Are you done, Hamna?
Yes, sir.
Now see, we are going for laws of refraction. So there are two laws of refraction. There are two laws of refraction. Basically, there are two laws of refraction. So I'm going to write both the laws and then I will explain to you what does this law means. So write with me. The incident ray the refracted ray and the normal normal to the interface to the interface of two transparent transparent media at the point of two transparent media at the point of incidence all lie in the same plane. All lie in the same plane. This is almost similar to first law of reflection, that the incident ray, the refracted ray, and the normal all lie in the same plane. This is basically the incident ray, the refracted ray, and the normal to the interface of two transparent medium, the surface of two transparent medium at the point of incidence, all lie in the same plane. Second is basically this is the second rule is for refractive index. We will see it. This is basically the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So basically what does this means is the angle of incidence we take sine with this, and the angle of refraction we take sine with that, and if we are going to take the ratio of sine I upon sine r, that will be constant. That will be constant. This law is known as Snell's law. This law is known as Snell's law. Snell's law of refraction. So please write it and let me know, Hamna, if you are done with this. Then I'll explain.
Are done.
Yeah, very good. So one of the main important points for rule 2 is that this is true. This is true for I greater than 0 and less than 90 degree. This is true for only this. Also, this I is for angle of incidence, and R is equal to angle of refraction. Angle of refraction. And if you are going to arrange this sentence in mathematical equation, sin I upon sin R will be equal to constant. sin I upon sin R will be equal to constant. So this is basically Snell's law. Please write it.
Certain.
Done. So this is basically laws of refraction. Now we will talk about refractive index. So what does this refractive index means? I'm going to explain. First of all, write the topic. And I'm going to write and then I will explain it. The extent of refractive index is the extent of change in direction, extent of change in direction that takes place in a given pair of medium. In a given pair of medium. So basically, how much it will bend, that defines a refractive index when a light goes from one medium to another. How much there will be change in the direction of light, that defines by refractive index. Or we can also define like the measure of bending of light ray when passing from one medium to another, when passing from one medium to another. So please write it, and then we will have uh, another definition from which we will have a mathematical equation of formula. Abdullah,
Yes, sir.
so did you complete laws of refraction?
Yes.
Oh,
Certain.
is this done, Abdullah? Abdullah,
Yes, sir.
is this done?
Sir, 1 minute, 1 minute.
Okay, take your time. Done, Abdullah.
Yes, sir.
Now see another definition of a refractive index is basically it can also be, that means a refractive index can also be defined as the ratio of the velocity of a light ray in an empty space to the velocity of light in a substance or in a medium. In a substance, first of all, you are going to correct it empty space in vacuum, just correct it in vacuum. So a refractive index is basically denoted by n, and n is equal to c upon v. This c is the speed of light in vacuum. This c, the speed of light in vacuum. Please write it. So we can define refractive index like if a ray is traveling from air to any substance, then refractive index will be equal to speed of light in vacuum upon speed of light in that substance or in that medium. Okay. Is that clear? Please write it. Let me know when you are finished. This refractive index is very important for class 10. Abdullah, are you done with this?
Yes, sir.
Thank you. Now see, this is for basically the speed of when a light travels from medium to any medium to air or you can call it vacuum. Do you know what is the speed of light in vacuum? Anyone? The speed of light in vacuum, Hamna, Abdullah. The refractive index of medium 2 with respect to WRT, that is stand for with respect to medium 1, with respect to medium 1 is given by the ratio of speed of light in medium speed of light in medium 1 and the speed of light in medium 2. Medium 2. So basically from this statement we are going to have a formula like n to 1. See, if a ray is traveling from 1 to 2, so the refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1. That means I'm going to write here the speed of light in medium 1 upon the speed of light in medium 2. So it is very important to note the sentence that whenever we need to calculate the refractive index with respect to which medium, so you can see refractive index of medium 2 with respect to medium 1. So we are going to have a formula speed of light in medium 1 upon speed of light in medium 2 with wherever it will be written as with respect to medium 1. So the speed of light in medium 1 will be in numerator and the speed of light in medium 2 will be in denominator. So please write it. And another reverse of this, the refractive index of medium 1. Now just I reverse the sentence. Medium 1 with respect to medium 2 is given by, you can see it, it will be n12. So here it will be speed of light in medium 2 upon speed of light in medium 1. So please write it. Please let me know when you're finished with this.
Sir, done.
Very good. Are you done, Abdullah?
Sir, finish.
Okay, I'm going to give you a question on this. The question is very easy. Light enters from air to glass, having a refractive index 1.50. What is the speed of light in glass? What is the speed of light in glass? The speed of light in vacuum. Is 3 into 10 raised to the power 8 meter per second. Please try it. Can you solve it? Hamna? Hamna, are you done with this? Abdullah? Hamna, are you there? So see, I'm going to explain. Light iterates from air to glass. So we are going to have a refractive index. It is going air to glass. So here we are going to use the formula refractive index is equal to C upon V. So C upon V in glass. That means velocity of light in glass. So velocity of light in this C means in vacuum. So it is 3 into 10 raised to the power 8 upon Vg. And what is the refractive index given? 1.5. So if you are going to calculate Vg, velocity of light in glass, it will be 3 into 10 raised to the power 8 upon 1.5. So it will be 2 into 8, 10 raised to the power 8 meter per second. Initially in the starting of the class, perhaps I told you the speed of light in glass is 2.5 into 10 raised to the power 8 meter per second, but the speed of light in glass is 2 into 10 raised to the power 8 meter per second. There was confusion. Okay, Hamna, Abdullah. Hamna and Abdullah, please speak up. Hamna, are you there?